Many people ask us, why is the Chappell Square ruled in the decimal inch and not in fractional sixteenths? This is a super relevant question. In the course of this video, we will explain exactly why this is, and why the 0.05 decimal inch ruling is the only logical choice. The primary design criteria for the Chappell Universal Square are twofold. The first being a powerful builder's calculator, and secondly, a precision layout tool. The Chappell Square is not designed to be your primary measuring rule. For this you will most often need something with a longer reach, such as a tape measure. In the first instance, as a builder's calculator, you can use the tables on the Chappell Square to determine your overall roof member lengths, along with all critical intersecting points and lengths for secondary members in the roof system. You can then use your Fat Max, or your favorite tape measure, in whatever ruling system rings your bell, metric, imperial, decimal, to mark the locations on the framing members. Once these calculations are completed, the Chappell Square can then be used as a precision layout tool. The factors in the tables will provide all the necessary angular ratios, to which you can apply to the square to make precision layout. As a layout tool, the primary design function of the Chappell Square is to allow quick and easy application of the factors in the tables to be applied immediately to the square, with no head scratching or conversions, to or from fractional units. The most practical way to accomplish this is with the 0.05 decimal inch ruling, just as in the tables, and as in a common calculator or iPhone. If anyone thinks the decimal inch ruling is confusing, imagine if the factors in the tables were stated in fractions, or if it were ruled in sixteenths. In that case, every time you wanted to apply the factors to the square you would be required to perform a fractional conversion. This in practice would prove to be untenable. Using decimal units as expressed in the tables, along with decimal inch rulings, is really the only sensible way to present these factors in a fluent working system. It also allows for an accuracy of within 1 to 10 thousandths by carrying each factor to 3 or 4 decimal places. As an example, the top line in the equal pitched rafter table has factors that relate to 3 aspects of a roof system. 1. The length of the common rafters per inch or any unit of run. 2. The difference in length of jack rafters per inch or any unit of spacing along the plate. And 3. The top cut of the jack rafter over 1 inch or any unit desired. The first 2 factors are length ratios and the third is an angular ratio. Case 1. In the first case, the factor expressed is the ratio of the length of the common rafter per inch of common run. As an example, the column under the number 7, specifying a 7/12 pitch, gives a first factor of 1.158. If we multiply this by our common run, say, 97.5 inches, we arrive at a rafter length of 112.905 inches. Using a decimal ruled tape measure, you could simply mark this directly at the 0.9 inch rule mark. Using a 16th ruled tape, you'd need to extrapolate somewhere between 7/8, 0.875, and 15/16, 0.9375. Not so difficult, but it requires having a working understanding and ability to mentally convert fractions to decimals, keeping us essentially in the black hole. By attempting to relate everything to fractional units, it becomes evident quite quickly that additional calculations will be necessary. Facing the depth and wealth of information presented in any one of the rafter tables, all of which will need to be applied to the square, in the timbers, you'll want to avoid the unnecessary thought processes required to wade through the black hole of fractional conversions at every step. Dealing with fractions inevitably leads to much head scratching and increases the potential for errors by making on-the-fly calculations in your head. Notwithstanding, there is a fraction to decimal conversion table on the Chappell Square for those attempting to escape the event horizon. If one happened to have a fancy calculator that spits out answers in fractions, would a readout of 112 and 181 200ths, or 37 and 7 125ths make you feel more comfortable? I can't see how, as these would need to be converted to something more sensible that could easily be read on the tape, requiring additional calculations, and leading you even deeper into the black hole. Evidence of this is on the fractional calculator itself, which shows the long string of steps it processes to come up with the results. It's enough to make one dizzy. The calculation in decimal units requires one equation and can be solved by a simple multiplication scribbled on a scrap of wood and a pencil. If your fancy calculator rounds off everything to the nearest 16th, you will find it that 0.056 to rounded to exactly 1/16. This emphatically backs up the argument I pose in a later posting titled, What's the difference between a Chappell and a 16th between friends? Now let's take a look at case 2. In the second case, we can use this ratio to determine the difference in length of jack rafters per inch of spacing. For a system with jack spacings of 32 inches on center, we have 32 times 1.158 equals 37.056. In this case, each jack would increase, or decrease, in length by 37.056 inches. Any increment you can imagine can be used with this factor to supply accurate results. Case 3. In the third case, we have an angular ratio that relates to the angle of the top cut of a jack rafter over any unit of 1. In this case, we would multiply the factor by 10 to equal 11.58 inches and use this on the tongue of the square over 10 inches on the body of the square. There is actually no need to multiply this in the case of using 10 as our base. All we need to do is simply slide the decimal point over one place to the right. Once this is aligned on the timber at 10 and 11.58 inches, marking along the tongue will give the accurate layout angle for the top cut on the timber. The Chappell ruling has a rule mark at 0.6, so it is a no-brainer applying this to the square. At this point, I would set the square up in a square jig at this ratio and use it to lay out all of the jack rafters. For the rest of that process, this square would be dedicated to jack rafters, or anything cut in the included roof plane. If by using these numbers, 11.58 and 10, does not allow the body or tongue of the square to cross over the full timber, you can extend these out to utilize more of the square by simply multiplying the given factor, 1.158 in our example, by any number on the body you choose. To use 15 on the body, multiply the given factor by 15 and this will be the location on the tongue. 15 times 1.158 equals 17.37. Jig it up for production and grace. In compound roof systems, you will be working with a number of angles such as common rafter pitch, hip or valley pitch, jack rafter and purlin top and side cut angles, etc. Understanding that any compound roof system combines 7 planes intersecting in a given space, at one point or another in the process you will be required to work with all of the angles generated as these planes intersect. However, there are 5 specifically that you will be working with extensively and require a square setup in a jig. In order to facilitate production and to avoid foolish mistakes, it is best to set up a square jig for each of these angles in the roof system at the outset. This will save an enormous amount of time, help to avoid confusion, and allow for a steady stream of non-thinking production and grace. As all Chappell students are aware, perfection and grace puts a smile on your face. However, production and grace will put your kids through college. It doesn't take a rocket scientist to see the simplicity of using the decimal format throughout this system. This not only prevents conversion mistakes, it also alleviates the frustration that comes with having to even think about converting fractions. As well, this underscores the importance of using the decimal ruling on the Chappell Square. Doing so makes it a complete and singular system. We hope you enjoyed this video, and make sure you look for more to be posted soon.